large boxes and small boxes. We have about 300 large boxes. So this is an example of a large box. So 300 of these pass through the pointer in a minute. So that's about 360 seconds. So if you calculate, it means that one of these small boxes, which are about 5 by 5 in a large box, one of these small boxes will take about 0.04 to pass through the pointer. Now, in order for you to know how much time it takes for a wave or a segment or an interval to go through the pointer, all you have to do is see how many of the small boxes were covered and say multiply that by 0.04. So what it is usually the P wave takes 2.5. All right, so 2.5 for the P wave. Then the segment at the end of the P and the start of the Q, which is usually known as the QR segment, takes another 2.5. So this is another 2.5 small boxes. Then you have the QRS complex. This one as well takes another 2.5 boxes. Okay, and your homework is to find out about the T segment. All right, but what I am going to give you is that the entire ventricular activity, okay, that's depolarization up to the end of repolarization, it takes about 0.4 seconds. All right, so all the way from here up to here, that's 0.4 seconds. So my question to you is, how many boxes is this? We can calculate how many small boxes the 2.5s are by just calculating 2.5 times 0.04. So that will give us 0.1 second. So we're talking about 0.1 second there, 0.1 second there, 0.1 second here, and then you guys can calculate how many boxes, how many small boxes are in 0.4. Awesome. So in order for us to calculate the heartbeat, we see what is going on in the RR interval. Why the RR interval? Because usually this is the space between the heartbeat. Everything has happened in this area. Okay, everything that is due to an impulse. So instead of us starting at P to P, we pick at the most observable points, which are RR. If we wanted, we could pick P to P and we could calculate, especially because the impulse starts here and the next impulse starts there. But in any case, we pick RR because these are the most observable components of the ECG. So if RR had, let us say, 20 small boxes, we would multiply that by 0.04, and then we would get that this is going to take 0.8. So all you have to do in order to calculate the number of beats per minute is say if it takes 0.8 seconds for one, okay, so this is seconds, for one beat. All right, what about how many beats are you going to have in 60 seconds? Because remember, it is beats per second. So this is going to be our x. So all you have to do is now say 60 times 1 over 0.8, or in short, just 60 over 0.8. So you're going to find, I think, something to the effect of 75 beats per minute. Okay, let me just write it down this side, or erase this so that I can write the answer down. So you're going to have 75 beats per minute. All right, awesome. So sometimes in exams we can give you the number of beats per minute, so that you can find our interval in terms of small boxes, or we can give you the number of boxes in small boxes and then ask you to find out the beats per minute, and then we can ask you whether it was an increase in heart rate or a decrease in heart rate. All right, so in the next video we'll be talking about arrhythmias. We'll be talking about increase and decrease in heart rates and so on and so forth.